Okay, so this time we're going to try solving this kind of equation. Again, we have to keep in mind that we have a restriction on the domain. So x is only allowed to exist between -10 and +10. And we're going to start by isolating the function itself as much as possible. Now this time you'll notice that we're working with the tan function. So we're going to try to isolate the tan function as much as possible, okay? And so we'll notice that there's a 2 multiplying the tan, and so we'll just get rid of that by division. So we'll end up with tan of pi by 5 times x is equal to -2 divided by 2 being -1. And so now we need to look for all of the tan value, all of the values of an angle along our standard unit circle that give us -1. So here it's going to be slightly different than for the sinusoidal functions, because we know that tan repeats itself every pi, not every 2 pi. So we're not going to worry about looking at the full unit circle. We're just going to look at half the unit circle, okay? So you can choose to look between 0 and 180 degrees, and you'll notice that the only time you get a tan value of -1 is when you're looking at 3 pi over 4. So what we have here is that pi over 5 times x is equal to 3 pi over 4. Okay, that's the only one we're going to worry about. But the fact that the unit circle repeats twice for the tan for every single rotation of the unit circle is going to be taken into account by saying that here we're going to multiply by pi n. Okay, because the period of rotation for a tan is pi and not 2 pi. So now we're going to take a look at this, and we're going to try to isolate for the x as much as possible. So we're going to divide both sides by pi, leaving us with x over 5 is equal to 3 over 4 plus n. And now we're going to take care of the divide by 5 by actually multiplying by 5. So we're going to have x is equal to 15 over 4 plus 5n. And again, n is allowed to be any value that's an integer. So it can be -1, it could be 5, it could be 10, it could be 1,000. It doesn't matter as long as it's a whole number. Okay. And just like before, we're going to take a look at all the possible values of x that fall within the range of -10 to 10. So if we start with an n value of 0, then that means that the first value we're looking at is going to be 15 over 4 plus 5 times 0, and 15 over 4 plus 5 times 0 is just 15 over 4. And that falls within the range of -10 to 10, so it's acceptable for us. So this one here is going to be a good value. Now if we take a look at n is equal to 1, well, that means that our second value is going to be at 15 over 4 plus 5 times 1. And 15 over 4 plus 5 times 1 is 15 over 4 plus 20 over 4, which is 35 over 4. And 35 over 4 is still less than +10, and so it still falls within the range. Now when we take a look at value n is equal to 2, so this one here is still acceptable. If we take a look at n is equal to 2, this is going to give us our third value for x, and that's going to be 15 over 4 plus 5 times 2, so 15 over 4 plus 15 over 4 plus 80 over, plus 40 over 4 is going to give us 55 over 4, and that falls outside of the range of -10 to 10, and so this value is not acceptable. Okay. Now you would think that you'd stop right there, but keep in mind we've only taken care of positive integers, and so maybe we should take a look at some negative integers as well. So instead of having n is equal to 1, 2, 3, or 4, 5, what if now we took a look at n is equal to -1? So if n was -1, this is going to give us our fourth possible value for x, and it's going to be 15 over 4 plus 5 times -1. So that's 15 over 4 minus 20 over 4, which is -5 over 4, and that falls within our range, so we can keep moving on. This is also acceptable. So now we're going to take a look at another n value. N is equal to -2. If n is equal to -2, we end up having 15 over 4 plus 5 times negative 2, and that's 15 over 4 minus 40 minus 40 over 4, and that will be negative 25 over 4. And that still falls within a range of negative 10 to 10, and so it's acceptable as well. And now we can go take a look at another value. N is equal to negative 3. That puts us at 15 over 4 plus 5 times negative 3. And that is equal to 15 over 4 minus 60 over 4, which is negative 45 over 4. And this falls outside of the range of negative 10 to 10. And so it is not acceptable. This value is not acceptable. And so we only have 4 possible acceptable values: 15 over 4, 35 over 4, negative 5 over 4, and negative 25 over 4. So we're going to write down our solutions to this particular equation. And we're just going to keep in mind that convention usually states that we're going to put the smallest values first. And so we're going to deal with negative 25 over 4, comma, negative 5 over 4, comma, 15 over 4, comma, 35 over 4. And we've just listed all the possible values of x between negative 10 and positive 10 that satisfy our equation that we have up at the top.